Let's talk about long operations, specifically long division. Say we have 45 divided by 3. You can write that statement like this, or as a fraction. For long division though, we'll be using this symbol, with the number we're dividing going on the inside. This is called the dividend. And the number we're dividing by going on the outside. This is called the divisor. The answer we get will go on the top here. That's what we call the quotient. So, how do we begin? Well, first you'll want to take this number 3 and ask yourself, how many times will 3 fit inside of 4? And the answer, of course, is 1. And you'll write that number right here, above the 4. Next, you'll do 1 times 3, which is 3, and you'll write that here. Next, you'll subtract 3 from 4, giving us 1. Then we'll bring down the next digit, 5, giving us 15. Now, if that was all a lot to process, don't worry, you'll be repeating that over and over, so you'll have lots of time to practice. So let's do that again. How many times does 3 go into 15 now? Well, 5 times, right? So we put a 5 up here. 5 times 3 is also 15. So when we do 15 minus 15, we get 0. We can stop here as there are no more numbers left in the dividend. And this 0 we get is what we call the remainder. In this case, because the remainder is 0, it means our answer is exactly 15. There's no decimal component. 45 divided by 3 is exactly 15. Now let's look at an example that will give you a remainder. Something like 44 divided by 3. And again, this could be presented to you as a fraction instead. Now let's set this up in the long division form, and we'll start with asking the question, how many times does 3 go into 4? Well, same as last time, it goes in once. So we put a 1 right here. 1 times 3 is 3, and 4 minus 3 is 1. Now we bring down the next digit, the 4, giving us 14. So how many times does 3 go into 14? Well, it only goes in 4 times. Yes, only 4. So 4 goes up here. Now 4 times 3 gives us a value of 12, and if you subtract, 14 minus 12 gives you 2. So now we got an answer of 14, with a remainder of 2. So what does that mean? Well, if you look up here for a moment at the fraction I gave you, currently it's an improper fraction. If you change it to be a mixed fraction, you get 14 and 2/3. The 14 comes from here, the 2 from your remainder, and the 3 is just the divisor. Now, if you've already watched my fraction forms video, you'll know what this means, but if not, this is just a number that's between 14 and 15. It's 14 and 2/3, or in other words, 14.666 continuously. Now, if you want your answer as a mixed fraction, 14 and 2/3 is great. If you want your answer as a decimal, you can remember that 2/3 is equal to those continuous 6's, or you can continue your long division. What do I mean? Well, watch this. First, I'll add a decimal here and a 0 behind it. And I'm allowed to do that because there are always zeros past your decimal. That's true for every number. Now I can bring that 0 down here to get 20, and I can repeat my process. 3 goes into 20 6 times, so I put a 6.
So I forgot to mention, see how I put the decimal in my answer right above the decimal in the dividend? It is very important that these are lined up like this. The location of the decimal in the dividend will always show you where the decimal goes in your quotient, or answer. Okay, let's continue.
Now 6 times 3 is 18, and 20 minus 18 is 2. Now remember, you already got a 2 back in the last step, and if you bring down another 0, you get 20 again. This entire step will repeat itself over and over and over, giving you an infinite string of 6's in your decimal. So once you notice that, you can also provide your final answer. Now let's do another example. Say we have 277 divided by 3. Again, we'll set this up in the same way. But when you look to see how many times 3 goes into 2, you'll realize that it doesn't, not even once. So instead, what you'll do is ask, how many times does 3 go into 27? And the answer to that would be 9. Notice I put the 9 over the 7 and not the 2, because we went into the whole number of 27 and not just the 2. So be careful of that. Next, we can do the 9 times 3, which is 27, and when we subtract, we'll get 0. Bring down the 7 next, and whenever you see a 0, 7 written like this, that just means the same thing as 7. The 0 in front doesn't change anything. Now, 3 goes into 7 twice, so 2 goes up here, and 2 times 3 is 6, 7 minus 6 is a 1, so 1 is your remainder, and you could stop there. This would mean that your answer is 92 and 1/3. Or you can continue your long division, borrow a 0 from here, 3 goes into 10 3 times, so we put a 3 on top, 3 times 3 is 9, then 10 minus 9 is 1, bring down another 0. This just keeps happening, and you'll see that this process repeats over and over and over, just like last time. So we expect here to get an infinite string of 3s. Now this answer makes sense. 1/3 is equal to 0.3333 continuously forever. Hopefully that's clear. Let's do another one. 25 divided by 4. After you set it up, you'll see that 4 doesn't go into 2, so we'll have it go into 25 instead. It goes in 6 times, and when you multiply 6 by 4, you get 24. Now 25 minus 24 is 1, so we have a remainder of 1. And now you can say your answer is 6 and 1/4, or 1/4. We could also write it as 6.25, if you know that 0.25 is the same as a quarter. But if you didn't know that, you could continue to do your long division. Bring down the 0, say 4 goes into 10 twice, so you put a 2 up here. 2 times 4 gives you 8, subtract, and you get 2. Bring down the next 0, and you have 20. 4 goes into 20 5 times, and you'll get a 5 up here. After that, you multiply and subtract again, and you'll get an answer of 0. And now you know you're all done. You get the same answer both ways. Now, last question here, and we have some decimals now. Say we have 65.25 divided by 4.5. One trick I like to use when dividing decimals is to turn the divisor into a whole number. So the 4.5, I'd like to change to be 45. And I can do that by moving this decimal place one spot to the right, or in other words, multiply the number by 10. Now, if I do this to the divisor, I also have to do it to the dividend. So 65.25 will have its decimal moved as well, one spot to the right, and it will become 652.5. And when I divide these two numbers, I'll get the exact same answer that I would by dividing the original two numbers, because the numbers have been increased proportionally. Kinda similar to when we have equivalent fractions. Now the reason I do this is because having a whole number for your divisor just makes things a little bit easier, in my opinion. So 45 goes into not 6, but 65 once. 1 times 45 is 45. Subtract, and you'll get 20. Now, bring down the 2. How many times does 45 go into 202? I think 4 times. So, I'll put 4. 4 times 45 is 180. Subtract, and we'll get 22. Next, bring down the 5. How many times does 45 go into 225? I think 5 times. So, 5 times 45 is 225, and when we subtract, we get 0, and now we're done. The answer we get is 14.5. Now, we have some practice questions here, so pause the video and give them a go, otherwise the answers will be revealed in 3 seconds. This has been long division. Be sure to check out my other videos on long operations, including long addition, subtraction, and multiplication. Remember to like or even subscribe to the channel if this video has been helpful, and feel free to check out some of my other over 100 videos covering various topics of high school mathematics. And of course, thanks for watching.